So, hello everyone. We are participated in a hackathon. So, we are team 404, team not found. The team members are me, Sadhya, Sairaj, and Daniel. So, let's move toward the presentation. Next slide. Yes. So we are given with a particular data set which is actually related to the airline, and we are the problem statement is regarding the profit prediction. So we are supposed to suppose to run the model and for machine learning and also predict the profit for the future data set. So let's move toward the same thing. So firstly, what particular things that we done in this hackathon or in our project is we cleaned the data set. We found that some kind of a data type, so we change it to the integer values which are actually in a float value, which is very important to find the accurate solution or find accurate result. And then we move toward after for checking any outlier, is there any outlier or not. Then also we need to find out the particular relation of a profit. So we actually check the correlation with every columns that present in the data set. So here is the correlation heat map which actually shows which columns are related to profit. Let's move toward. So I will like to hand over to Sairaj. So over to you, Sairaj.
Hi everyone. Feature engineering. In generation new, it generation new meaningful features from existing data to improve model accuracy. It reduces data complexity through PCA, making models faster and more efficient. It selects the most relevant features based on their relationship with the target variable. It designed for easy reuse, ensure feature engineering across dataset. It provides insight into feature importance, helping understand which factors drive prediction. Over to Sanya.
Okay, so as Sairaj explained that what exactly feature engineering is and how important it is. So we have the particular like some 7 to 12 columns with us. So feature engineering actually help us to know the better insight, to drive the better insight. So we did the feature engineering stuff. So let's move toward the model development. So how which kind of algorithm we take and why we take the particular thing, and how we implement that and how we train that thing. So first of all, we take a particular regression model which is a random forest regression, which over the linear regression model. So firstly we did the linear regression model, but actually we failed, and that's why we found some kind of a stuff related to random forest regression, which is actually handles the non-linearity, which capture the complex integration and manage the mixed data without any multi-collinearity issues. So that's why it is very effective for us. And we also use the standard scalar over the min max scalar. Actually it's we found that it's very better to handle the outliers also, as our data have the outliers. And the most important thing here is after training the model, we train the model in particular split data set. So we have the data set which is very huge. It has a 2 lakh of rows. So that's why we split the data set and train the particular model with relate with like 101 rows or something, and run the model. And we found that we train the model particularly with seed value is 42, which is we can say that it is very standard seed value. And also we after the running of the model, after training and testing all the stuff, so we found that our model is accurately trained, which actually accurately predict the particular profit on the historical data that we have provided. So after the model training and testing, we found that our random forest model derives accurate data driven airline profit prediction, so which enable us to find out the particular business insight, which actually tell us that how the peoples are actually very engaging with the airlines, and how they ask like the cost proficiency is very impactful on the profit that made by the particular airline or air flight. So here is the statement that MSC we found is nearly 0.09, which is actually we found the MSC, which is 3.399 into 10 raised to power minus 22, which is accurately or nearly with respect to that negative value, which is actually 0.0. So yes, we can say that our model is 100, not 100%, but our model is ready to move for the future prediction of the airlines. So yes, here are the brief introduction about the machine learning model that we are worked on. So I would like to explain the further stuff which is regarding the dashboard. Over to you, Daniel.
Thank you, Sadhya and Sairaj, for explaining the very insightful knowledge in respect to the machine learning as well as future engineering. I will next move on to the main important part of this dashboard, the Power BI we integrated with the ML model, and I will show the insightful dashboard. First of all, why we create the dashboard? Because we implement the KPI model, and then the slide number is first one, total revenue and total profit as well as the total net profit margin. And with respect to the slicer, we use that flight number. Depend upon the each flight number, we can change the data set accordingly. And then first of all, first graph are showing the total revenue versus total cost. This is the very insightful knowledge showing with respect to the month. And also we highlighting with the different color to understand better for total cost and total revenue. And then move forward to the next graph, the sum of revenue by month. This is in y-axis sum of revenue, and this is the month, and the pointer are showing that's the value of total revenue by month. And we use the highlighted colors to understand better insightful graph. Then I move forward to next slide in Power BI, insightful. Then first of all, our total profit by total fuel cost ratio. This pie chart are showing the both different variation with respect to their color. And also next part are the total profit by the total cost per ASK. This is the showing the total profit by cost per ASK. And if you change accordingly, we use the slicer for revenue per seat. If you change any revenue model in this data set, then whole graph will change accordingly with respect to their per seat revenue. And next, the total profit by month. But we used the implementing some insightful knowledge in this. If you change, select or in quarter one, quarter two, quarter three, and quarter four, their respectively, they accordingly data will change. And then move forward to next flight number versus total profit. If you select some flight number, the data will showing and the table is showing the total profit and also highlighting the total profit. And then move forward to next Power BI dashboard inside. This is our next insightful knowledge, total delay minute per load factor. And also next graph are the total delay minutes and total load factor by flight number. We use the scatter plot to understand better for flight number with respect to the total delay minutes and total load factor. If we select any pointer in this scalar graph, then the data accordingly change with respect to their flight number. And also if you select in this slicer box flight number, they also the graph will change. And also the next graph are the total profit per seat and total revenue. With respect to the total profit, we highlighting different color variation in the donut chart. Then move forward to the total profit and total of ancillary revenue by month. We add some little bit highlight sum of profit USD with respect to month. And I move forward to next last part of our presentation, our business impact. Why we choose this dashboard and why we train the model? Because in the future we use or implementing the business insightful knowledge for airline industry. Then we revenue optimization through this dashboard as well as the ML prediction model, and also cost efficiency as well as the predicting and controlling operational expenses. And our most business inspect full knowledge are the customer-centric decisions. If you choose any demanding for forecasting for price strategies for airlines, then this model are very insightful knowledge showing the business impact. Next, I will conclude it with a final insightful data-driven strategy can improve airline profitability by 50 to 20%. And also the future scope are incorporated in real data streaming and deploy predictive model for fuel cost adjustment. And also you can automate decision making using AI and cloud computing. Thank you for listening our presentation.